We want to take a look at the derivative of the natural exponential function. Well, first of all, let's discuss exponential functions. They are functions that look like something like 2 to the x, 3 to the x, 1/4 to the x. The variable in an exponential function is the exponent, and the base is just some fixed number. Okay, so those are exponential functions. Now, what is the natural exponential function? It doesn't actually seem so natural at first glance. The natural exponential function is the function e, the number e, to the power of x. And e is not a variable here. E is an irrational number like pi. In fact, e is approximately 2.71828, etc. Okay? So why is this so natural? Well, you may have heard natural logarithms. Natural logarithms have a base of e as well. E has some very nice properties. In particular, in calculus, it has the following property. The derivative of the function e to the x is in fact itself e to the x. Okay, so that's pretty interesting. If you investigate this a little bit, if you use the limit definition of derivative, you'll see that you have the limit as h goes to 0 of f of x plus h minus f of x all over h. And if you look at this, you get the limit as h goes to 0. F of x plus h, using this function, is e to the x plus h minus e to the x, all divided by h. And now what we can do is, you may want to investigate this a little more if you're not very comfortable with it, but I'm going to factor out an e to the x on top, and that's going to leave e to the h minus 1, and that's all over h. Okay, this is and it's h. Now, since this e to the x is completely independent of this h, I'm going to pull that out to the front of the limit so that I have that e to the x that's independent times the limit as h goes to 0 of, sorry, I don't want the parentheses there, of e to the h minus 1 all over h. And remember, this is f prime of x. Now, if we're wanting this property that we stated up here, if we want the function to equal the derivative, f of x to equal f prime of x, then what we want is for f prime of x to be e to the x as well. And if we want that, this is what we'd have. And if you divided both sides by e to the x, then you would just get 1 on the left, and you will see that 1 equals the limit as h approaches 0 of e to the h minus 1 over h. So e comes about by trying to get, helps us find a function, and we'll say specifically an exponential function, whose derivative is itself. Okay? So e is the number for which this statement is true. E satisfies the property that the limit as h approaches 0 of e to the h minus 1 all over h equals 1. You may also look at this and recognize that that would be f prime of 0 in this case. So the derivative of the function e to the x at 0 is 1. The slope of the tangent line at 0 is 1 for the function e to the x. Okay, those are all the equivalent statements. And so you could investigate this by calculating this limit numerically using a calculator or something. And you should check it out, right? Plug in numbers close to 0 for h and see that you get numbers close to 1 for the limit. But e is a number that satisfies this property, and the function e to the x satisfies this property that its derivative equals itself. So this is the main point of the video, and you could interpret it many ways. We've already said e to the x is its own derivative. Another way to interpret this, which is fairly interesting, the slope of the tangent line at some x value a, and remember the slope of the tangent line at a is called f prime of a, equals y at a, right? The y value of a, and that is f of a. So f of a and f prime of a are equal. So if you graph this function, e to the x, it looks something like this. The cool thing about it is, say you're at 2 and you want to know the slope of the tangent line here, that would be this. The slope of the tangent line is equal to the y value for that function, which happens to be e to the x, so e squared would be the slope of the tangent line here, which is the y value. So you get this direct correlation that at any point on the graph, the slope of the tangent line is just simply equal to the y value at that point.